that if your utility function rapidly converges to 1, you would give a much higher utility to low benefits. So in this case, why you didn't take an allocation of 28? The reason is that you have a very, of course, you have an utility of 0 to this allocation, to this benefit, which is the minimum, but also if you had here an intermediate benefit, an higher value of utility, then you would prefer this allocation, even if this allocation may give to you a lower benefit. Because, of course, if you look at this allocation that we choose, basically it's an allocation that has 3 high benefits in all 3 cases. So basically, if you give high utility to low benefits, you increase your preference for low benefits, which means that you are more prudent, meaning that even to low benefits, you give a high utility. And if you give a high utility to low benefits, at the end, you end up with a decision that may give to you low benefits, because you believe that they are highly useful for you. So basically, if your utility function rapidly converges to 1, you have a prudent choice. If your utility function converges to 1 very slowly, then you are more liking the risk, you are more prone to risk. So propensity to risk means a utility function that gives high utility only to high benefits. A prudent attitude corresponds to a utility function that gives also a very high utility to low benefits. Okay, good. So if you are looking for very good benefits and you accept the risk of getting also lower ones, then adopt a slowly increasing utility function. This is utility theory. And I think I basically finished here, yes, because yes. Here there are some final considerations, and basically there are the pros and cons of this method, which we already considered basically, because you know, the pros is that you have the opportunity to take into account the adversity or propensity to risk, and it is a transparent method, and it's more objective. And the cons are that, you know, to define the utility function is complicated, because if you have to deal with just one user, then it's relatively easy. If you have more than one user, of course, they will give different utilities to different benefits, and then reaching a compromise can be difficult. And also, it's difficult to assign utility to extremely rare events. So basically, you know, if you have a set of benefits that is quite limited, then it's easy for a user to give them an utility. But if you have a very diverse set of benefits, ranging from 0 and an extraordinary high one, and these extremes can occur with very low probability, then it's difficult to give a utility to these events. And because you can assign a utility to money that you have experience on, for instance, but if you don't have any experience on a lot of money, it's difficult for you to give a utility to a lot of money. If one told you what would you make with 10 million euro, you would be a bit, concerned. If you ask the same question to, I don't know, Berlusconi knows what to do with 10 million euros, okay? So, and the same for any other kind of very rich person. So if you have a very relevant confidence with the money, then of course you can evaluate the utility of a lot of money. If you don't have this experience, and the same for real poverty, it's difficult for us to evaluate what are the consequences of real poverty if we don't have any experience of that. And it's almost impossible in the modern age to evaluate the consequences of, for instance, of losing everything, because it's a situation in which we are not used to. And so these extreme events are difficult to evaluate by the man on the street if he has not experience on that. It's, we experience the same. When we try to evaluate the risk of the dam breaking, it's very difficult to evaluate what is the consequence. And the people cannot really figure out what they are because they don't have any experience. They may have experience with the moderate floods, but not with extreme floods. And so these are basically the definition of the utility here is the problem. So you shift all the challenges on this estimation of utility. Still, I think this is really a useful solution. And for instance, I want to give you an example. We are now trying in the department the use of utility functions to calibrate hydrological models. Instead of optimizing the net efficiency, of optimizing the sum of squares, which are some quantities that you can't really quantify what they mean. We are trying to transform, for instance, the net efficiency into a utility function. And let me better explain. The utility function is determined in this way. For instance, if I'm not interested in simulating the droughts, I could assign utility 1 to any simulation done for the droughts, because it doesn't matter to me. Whatever simulation comes out, I give utility 1. Instead, for the floods where I'm interested in, I give a utility of 0 if the error is greater than 20%, and then a linear increase from 0 to 1 if the error is included in the range 20%, 0%. So I'm focusing basically only on the floods, and there I give utility 0 if the error is greater than 20%. And for the droughts, I give utility 1 to every simulation that comes out. This is a solution that allows us, in a subjective but very transparent way, to specify what we want. And in this case, what I want is to reach a precision, an error that is at most 20% in the simulation of floods, just floods. If I am interested on droughts, I could do the same. Give utility 1 for any simulation related to floods. Whatever comes out is fine, and concentrate only on the droughts, and that means, for instance, a maximum error of 20%. This is very useful because you basically transfer the calibration problem to minimization or optimization of something, objective function that you can't really figure out what it means, and you move the problem to the optimization of a quantity that you really understand what it means. It's utility, and focuses on the type of river flow, in this case, to the river flow values you are most interested in. So I think indeed this is a useful solution for taking decisions. No matter if the decision is to find the optimal allocation of water or to find the optimal parameter values for an hydrological model. Good. Just to mention that the final slides are just showing an example of a relevant water resources management problem. I'm not mentioning it now. I'm just, because it's something that is not relevant for the exam, still it's very interesting because it's the management of the reservoirs along the Nile River. I will talk on this on Friday, just a few minutes, just to show you something of practical, to close the subject. Now, we have 15 minutes. Let me go back to the slides that I skipped, because this is still an interesting story. And let's start once again from this objective function, which is depicted here. So what is definitely the most simplest way of taking uncertainty into account? Utility is a complicated way. I treated utility first because being complicated, I wanted to introduce you with an extensive lecture. Maybe that I was not successful in introducing it well, but anyway, I thought that it deserved more attention. But there is a simpler solution, not really to select the best decision, but to assess the impact of uncertainty, which is, you know, interesting because indeed, an essential premise that I skipped is that if uncertainty has a relevant impact, then it's worth taking into account. If the impact on your decision is really small, you may also discard it. Okay? Because, you know, maybe that these parameters of the objective function are uncertain, but at the end you may realize that your decision doesn't change. No matter if you take one possible value or the opposite one, you may see that the optimal decision that you take is not affected. So in this case, why should one care about uncertainty? So the first step indeed is to assess the impact of uncertainty on decision. And this is done through sensitivity analysis, which is an extremely important process, sensitivity analysis, that you have to know. Because, you know, it is used in water resources management quite extensively to assess the impact of decisions. In this case, to assess the impact of uncertainty of the decision. So basically, what is the concept? As I said, it's extremely simple. And you have parameters in the objective function that are uncertain. Let's see what happens if you change them. This is the concept. So you have A, the parameter A that is uncertain. Let's see what happens if you change it. Does your final decision change? Yes, no. If it doesn't change, let's discard the uncertainty on A. If it changes, let's see how much. And this is sensitivity analysis. Basically, you have a model. Whatever the model is, an hydrological model or a decision model, you change the model parameters and assess the impact on the results. This is sensitivity analysis. Sensitivity means sensitivity of the results to the parameters. Again, keep in mind that this is not an alternative to decision criteria. This is a preliminary analysis. There is an extended body of literature on sensitivity analysis in several different disciplines. If you go to Wikipedia, for sure, I didn't check, but for sure there is an entry for sensitivity analysis. Now let's see an example. You just have to draw a table. Let's consider our function here, this one. And let's see what happens if we change the parameters. So basically you draw a table where you have here a number of cases, and the first case corresponds to no perturbation of the parameter. So you get this optimal decision and this optimal benefit. Now, let's consider parameter A. Let's increase it 25%. You get to an optimal decision of 41 with that benefit. Now let's decrease it 25%. Again, another case. And you can do the same for the other parameters. That's it. This is your sensitivity analysis. Your question now could be, why 25%? Unfortunately, this is subjective. So if you have an indication of the uncertainty in the parameters, like if you knew that A is uncertain of 25%, then of course it's justified to take the extremes. If you don't have any indication, you have to make a reasonable assumption of uncertainty in each parameter. So don't take 25% as a universal suggestion. You have to change the parameters in a reasonable manner. And this is an open challenge, depending on the problem that you have at hand. Okay, and then of course, one may say, let's introduce some quantitative evaluation of these changes. So basically, look at the changes in the benefit. Are they important or not? So, of course, it depends on the considered case study, but we can also introduce some quantitative indexes for evaluating it. Could be percentage change, for instance, or there are these 3 indexes that you can use. Now, let me conclude today's lecture by saying, if you take your exam on the 26th of May, you can discard sensitivity analysis. I won't ask any question on it, the 26th of May. If you take your exam later, please let me the possibility of asking questions on this and just go through the slides, and also these 3 indexes are very easy to understand. I tell you, and I have no doubt that you can easily understand what they mean. And in order to understand the indexes, you also need to have a look at the previous slide here. But let me, because I think that today the lecture was just enough, let's not to concentrate on this, which is, again, very easy. And in case you have problems in understanding this part, you can just consult with me. You have time to do so because there is 1 month before the 12th of June, but again, on May 26th, I won't ask this. I'm sure that I will not meet all of you on Friday, because Friday we have just exercises. And for those of you who are not attending on Friday, let me thank you very much. And you are losing my final speech, which is basically a speech that I tell you that I really enjoyed this year lectures, because I always had the feeling that you were behind me and attending my explanations and understanding them. Maybe that my feeling was wrong. And, but I wanted to convey my happiness and satisfaction for this year's subject. And let me say that since I started the subject in English, this is the first year in which I can really see that the audience is like attending as I would like to. And but in any case, I'm not. Let me speak in a more extensive way on this on Friday. Okay. Thank you.